Okay, in this video, we're going to talk about antiderivatives. So we'll use a big F, capital F, to represent an antiderivative of a function little f of x. And that works if the derivative of big F is equal to little f. So we have f of x, and we'll take the derivative. So f prime of x would equal little f of x. And then, of course, what that means also is that the second derivative of big F of x is equal to the first derivative of little f of x. So what we've been doing is taking the derivative of little f of x. What we're going to do is go the other way to find the antiderivative. Okay, so we'll have a family of antiderivatives, and basically we use the indefinite integral. So we have this integral sign, we have our function f of x, and then we have the d of x. So the integral sign and the d of x are the two components that indicate this indefinite integral, this anti-differentiation operation. Okay, so the big F is actually going to be a family of antiderivatives. And basically, the difference in all the members of this family is this constant of integration. And this is illustrated in this picture over here. In this picture, we have little f of x is equal to 1, and big F of x is the antiderivative of 1 is x, because the derivative of x is 1. But we add this constant because the derivative of that constant is 0. So we can have x plus 3.5, 2, 0, minus 1, minus 3. They all have the same derivative, right, which is 1. Right? They all have a slope of 1. Okay, so looking at some of our formulas that we learned, the differentiation formulas, we basically undo those. So for instance, the power rule, this is the power rule for differentiation, which says that we take the exponent, we multiply it out in front, and we subtract 1. Well, we want to undo that. So the way we undo that is we add 1 to the exponent, and we divide by the result. And of course, for all of these, we need to include this plus c, because if we were to take the derivative of this side here, what we would get is we would bring that n plus 1 down in front, which would cancel the n plus 1 here. Then we'd subtract 1 from the result to get x to the n, and then the derivative of c is 0. Now, this doesn't work if n is equal to -1. If n is equal to -1, we have this down here, we have 1 over x. Right? And then the antiderivative of that, or the indefinite integral of that, is the natural log of x plus c, because, again, the derivative of the natural log of x plus c is 1 over x. Okay, so let's go ahead and apply this to some problems and see how this works. So we have, in this case, we're using f prime of x, little f prime of x, and we want to find f of x. So let's first rewrite this so that we have, instead of these radical signs, we have exponents. So this is going to be 4x to the 2/3 minus 5x to the -3/5 plus 2. And if we take the antiderivative, basically then we find f of x, and we're basically going to add 1 to the exponent. So 2/3 plus 1, or plus 3/3, is 5/3. And then we divide by that result. So we have 4x to the 5/3, and then we divide by 5/3. We'll clean this up in a minute. For the second term, if we add 1 to -3/5, we add 5/5. That becomes x to the 2/5, positive 2/5. And of course, then we divide by that 2/5. And over here, we have 2, a constant. Well, the antiderivative of a constant is just x, so 2x. And then we have our plus c, right? So now we can clean this up by flipping all these denominators around and up into the numerator. So this gives us a 12/5 x to the 5/3. This becomes 25 over 2 x to the 2/5 plus 2x plus c, and that's our answer, our antiderivative of f prime of x here on this first problem. On this second problem, then, we already have it written written with the exponents here. It's dy dx, so what we're looking for is y. So what we'll do is the same procedure for this first term. We'll add 1 to the exponent and divide by the result. So if we add 1 to -2, we get -1. So this gives us x to the -1, and then we have to divide by -1, which is the same as multiplying by -1. In this case, we have an x to the -1. Well, that's this up here, this natural log, right? And so that's going to be minus the natural log of the absolute value of x. And again, we'll have our c constant. Right now, we would really have a plus c constant from each of these, but we'll just combine those since they're arbitrary. They're unknown. We don't know what they are. We can just combine them into one constant of integration for both terms, right? So this is it. We can't really simplify that. We can write maybe x to the -1 is 1 over x, but that's good enough. Okay, for this last problem, again, we have y prime, so we want to find y. Right, we want to find, again, the function y that has this y prime as its derivative. Now, so what we need to do is, we know the derivative of sine is cosine, but what is the antiderivative of sine? Well, the antiderivative, or the integral of sine, is negative cosine. So this becomes, so the y here becomes negative cosine of x, and then we do the power rule idea here, right? We add 1, which would give us a 5/2. We divide by 5/2, but that flips up to be 2/5 x to the 5/2, and then we have our plus c again. So that's the integral or antiderivative, the indefinite integral or antiderivative. We'll talk about definite integrals and what that means later on. Okay, so now we'll use the sort of official notation, this indefinite integral notation with the integral sign. Remember, the integral sign and the dx. These are essential components of doing an indefinite integral. Okay, but it's essentially the same sort of thing. So we want to find the antiderivative of 3x. Well, that's 3x to the 1. So we add 1 to that power. So that becomes 3x squared, and then we divide by the 2. So 3/2 x squared. The antiderivative of e to the x is, if we look in our table here, if we have that in our table, we don't have that one in our table, but we know that the derivative of e to the x is just e to the x. So the antiderivative, or the indefinite integral of e to the x, is going to be e to the x also, and then we'll have that plus c again. So that's the answer there. For this one here, we have the 3e to the x, so that's going to be, again, 3e to the x. The 3 is a constant, so that stays put. We have plus 9 over x, or that's 9x to the -1. So that becomes, the 9 is a constant, that stays. And then we have the natural log, and we'll use the absolute value of x. And then we have the plus c, right? So let me just put boxes around these. That's the answer to the first one. This is the answer to the second one. We can't simplify it at all. And then for this one, for the third one, the antiderivative, or the integral of 4, is going to be 4x. And then for negative cosine of x, we'll have negative sine of x, because the derivative of sine of x is cosine of x, right? And then we also have the plus c. So those are the answers for that problem, for those problems. Now, sometimes we want to find a particular solution. Remember, all these solutions up here are family of solutions, and the families are given by basically different values of that constant. If we want to find a particular solution, then we need to find a value of that constant. And what we need is one more piece of information. So for instance, on this problem, we want to find h such that the derivative h prime is equal to 8t to the third plus 5. And then we also want to evaluate the function so that when the t is equal to 1, our h of 1 is equal to -4. Okay, so let's first find the antiderivative, or the integral, right? It's going to be 8t cubed is going to be 8t to the 4th. We add 1 to the exponent, divide by that result, and then we have plus 5t, right? The antiderivative of a constant is that constant times the variable, just like the derivative, again, like the derivative of 5t is 5, but we're going the other way. And then we have our constant here. So these will simplify down. That'll just be 2. So we get 2t to the fourth plus 5t plus c. And now what we want to do is go ahead and substitute that in that 1. So we have 2 times 1 to the fourth plus 5 times 1 plus c, and that equals -4. So now what we do is we solve for c. So 1 to the fourth is 1, 2 times 1 is 2, 2 plus 5 is 7, and if we subtract 7 from both sides, -4 minus 7 is -11. So that's our constant. And now our function is 2t to the fourth plus 5t minus 11. And of course, we can check this by finding the derivative. H prime of t, the 4 comes down by the power rule, multiplies the 2 to give us 8. We subtract 1 from the exponent, 8t cubed, plus the derivative of 5t, which is just 5. And the derivative of 11 is 0. So we get 8t cubed plus 5, which is what we had up here. So now we know that that answer is correct. Okay, and that's it.